Hi, my name is Pat Keeney. I'm an instructional designer with K-12. I'm one of the team of people who created this course, and I'm here to aid with some of the more difficult parts of this lab. Part of any scientific work is creating and testing an apparatus or machine before we try to take data from it. In this lab, the apparatus we will work on is a long ramp. The scientific principle we will be exploring is the law of conservation of energy. The ramp is built in sections. The first section is made up of 3 pieces. The second is longer and consists of the remaining connectors and plastic pieces. Connecting the 2 sections in a way that the ball will roll seamlessly down the ramp is critical to the lab. Connect the 2 parts as smoothly and well aligned as possible so that little energy will be lost when the ball changes direction. You might need to add some modeling clay to help keep it stable. Let's see how well it works. Roll the steel ball down the ramp and check for problems. To change the angle of the incline, just move the books forward or back under the inclined piece. Check the track at various angles to be sure that the marble continues to roll smoothly. Raise the track with some modeling clay if needed. When you're satisfied with the way that the track works, you're almost ready to start collecting data. Start by moving the books to the very end of the track to create the lowest angle possible. Measure the distance from the end of the incline to the end of the track and record that distance. You'll need to know the mass of the ball, so we'll measure it with the scale. To do this, you may need to place a small amount of modeling clay on the scale, then press tare. This will zero the scale for you again. Now, place the ball securely on the clay to take an accurate measurement. You will also need to measure the angle every time you change it. The height of the incline above the table will vary with each new angle and will have to be checked and recorded. Now you can let the ball roll and take data. At the same time, you'll be checking how long it takes the ball to roll a measured distance. Start the stopwatch when the ball reaches the beginning of the horizontal track and stop it when it reaches the end. Be sure, of course, to record these measurements. After the lab, think about possible factors that might have affected your results. How might things like moving air, vibrations, or how the ball was released have caused changes? Also, think about how the effects that you saw in this experiment have real-life applications. This simple experiment gives us a good idea of the thought process and procedures used for creating more complex experiments.